Hello and welcome to CENOS introduction video. This is a video meant for first-time users who are just starting to simulate with CENOS. In this video we will learn what a simulation is and what steps are needed to create a simulation. We will also look into different simulation creation approaches available in CENOS, as well as go over the biggest mistakes made by first-time users, which you should consider if you want to create a successful simulation. Please note that even though the contents discussed in the following minutes are useful for the first-time users, it does not replace a full training with our engineers. CENOS is a simulation software designed for induction heating. But before we dive in the workings of it, we need to understand what a simulation is. A simulation is a mathematical model of a real-life system, which in our case would be an induction heating system. This mathematical model consists of geometrical definition of the system, which we call simulation domain, and of physics definition of that system, which together allows us to predict physical phenomena occurring within the system, such as induction heating. If we look at the CENOS window, we can see that the screen is divided into three parts, each representing a step in a simulation. First, we create and define geometry. Then we enter physical parameters of the system, and in the end we run the simulation and see the results emerging from our definitions. If we go a little deeper into geometry definition, you will notice that the geometry creation part actually consists of three subparts. First, you prepare the geometrical model, meaning that you either create CAD of your system in CENOS or import elsewhere created CAD in STEP or IGS format. In the second step, partition and group, you need to unite your model in one single simulation domain, and from that extract and name volumes and surfaces of your system, such as workpiece, inductor and terminals. This step is very important because the names and parts created in this step will be used for mesh creation and physics definition. In the last step, you prepare your simulation domain for calculation by creating a numerical grid, which is known as meshing. The rest remains as we discussed previously. After geometry definition, we define the physical side of the system, such as frequency, current and materials, and when the system is completely defined and calculated, predictions about physical phenomena such as heating will be presented. There are different ways on how to create simulations in CENOS, each with its pros and cons, which is why you need to understand which approach would be the most suitable for your project. Templates are the easiest simulation creation approach in CENOS. They are designed for 2D axial-symmetric static systems. Templates are perfect for the first-time users, as you can choose from existing geometry templates of workpiece, inductor and concentrators. You don't need to create air or mesh separately, as it is done automatically, and physics are already partially predefined, leaving you with only the most important decisions, such as frequency, current or materials, which allows you to simply play around and acquire an insight in simulation with CENOS. From CAD is an approach used for simple 3D simulations. It allows you to import one or more step files of your system directly into CENOS and define volume and surface groups such as workpiece and terminals in an interactive screen. As the air domain and mesh generation is done automatically, you don't need to do additional manual geometry modifications before you can run the simulation. This approach is great for fast 3D simulation setup, as you do not need to spend a lot of time in geometry definition. Please note that air is being generated automatically only for full 3D geometries, meaning that if you want to simulate symmetry cases such as slice, you will need to create air domain separately and import it along with other step files. For more advanced users, CENOS offers fully manual geometry and mesh creation approach, Advanced Geometry Editor. It allows to create geometry and mesh from scratch in CENOS geometry modeling tool Salom. This approach gives full control over geometry and mesh, but also requires extensive knowledge about meshing, which is why we do not advise to start with this approach. Import, create and modify geometry, define any kind of movement and optimize the mesh to enjoy the full power of CENOS. Before diving into simulation, there are a couple of things to know, which are vital for simulation and will help to save a lot of time in simulation setup and analysis as to why the simulation isn't working. If you are new to CENOS, some tips will not be clear to you now, but nevertheless, please pay attention to remember them when you will get to that point. You can also get more detailed description of each tip in our documentation page, documentation.cenos-platform.com. Every simulation starts with the geometry. If you have not simplified the geometry, fixed CAD quality or made sure the positioning is correct, you will have a hard time getting the simulation to work. First and foremost is to consider CAD quality requirements. Take away every small hole, fillet or other details which are not relevant for the simulation but will make meshing harder and increase the calculation time if you do leave them there. Avoid building your geometry from smaller volumes and always fuse them together before importing it in CENOS. If you have axial symmetric case and you want to simulate the rotation of the workpiece or only a 2D cut plane of the axial symmetric geometry, you need to remember that rotation axis of the workpiece must always be Z-axis. And for 2D axial symmetric geometries, symmetry axis must be Y-axis. As the air domain is necessary for correct calculation of the system, there are some things to remember regarding the airbox around your geometry. You should not create the airbox too small, otherwise the results could be incorrect. A good rule is to make the air domain around 3 times larger than the induction system in it in every direction. For 3D simulations, remember that inductor terminals must always be on the same plane as one of the airbox sides. If your geometry is at any level symmetrical, use that and simulate only half, quarter or a slice of the full geometry using symmetry boundary conditions available in CENOS. When it comes to meshing, there are mainly 2 things to remember for those who are using Advanced Geometry Editor. Always create proper resolution for the skin layer in inductor and workpiece, because without it in mesh, the electromagnetic and thermal results of the simulation will be incorrect. Don't get confused when you see viscous layers function to resolve the skin layer. This is simply an analogical tool from fluid dynamics which is used for mesh layer creation in our mesh editor. Pay close attention to the mesh size, especially for 3D simulations. If element count goes above 300,000 elements, consider simplifying your simulation through geometry or symmetry, as simulations with large mesh will take much longer to calculate. In physics setup, problems are mostly connected with understanding the functionality of some of the physics definitions. Those who are calculating with current as their power input should remember that current defined in CENOS is amplitude, not RMS current, which means that if you know the RMS value of the current flowing through your inductor, you should multiply it by square root of 2 before you enter it in CENOS. Regarding movement, which is more complex than simple rotation of fully axial symmetric workpiece, such as scanning, it can only be defined through Advanced Geometry Editor. If you have simple rotation of an axial symmetric workpiece, you can simulate it using from CAD approach, but for other movement types use Advanced Geometry Editor. If you are using from CAD approach to simulate symmetry cases such as slice, remember that automatic airbox generation works only for full geometries, meaning that you have to create and import air as CAD with the rest of your geometry. If you are calculating a symmetry case, don't forget to change symmetry definition and enter angle of your slice to calculate power and other parameters for the full system. If you have additional questions about how to use CENOS functionality, visit our documentation page. It contains numerous tutorials, how-to and explained articles, where you can find answers to your questions. This concludes the introduction to CENOS. If you have additional questions, please contact CENOS team. Thanks for watching and good luck in your projects.